day 2 of vectors. So we're going to talk more about magnitude and direction. So magnitude is the length of the actual vector. Yesterday we had component form, or Tuesday, and now we're going to talk about the magnitude and the direction. This is a new notation that you've never seen before. You use like what looks like an absolute value sign on a vector, and that is the notation used. Some places will do like a double absolute values, and you can put the symbol above or not. But I just use single because it's easier. Okay, so basically what we're going to do here is, if you kind of split this up like this, the left side is for if you're given the magnitude and the direction. So you'd be given how long the vector is, and you'd be given direction, and direction is theta, an angle from the positive x-axis. If you want to go to component form to find the horizontal component, you take the magnitude times cosine of the angle, and to find the vertical component, you take the magnitude times sine of the angle. So here's your formulas. A, which is the horizontal, is magnitude cosine theta. B, which is vertical, is magnitude sine theta. So then the component form AB, you could also think of it like this. Component form could be magnitude cosine theta, comma, magnitude, oops, that doesn't look very good, magnitude sine theta. And that's what you're going to do. This is given magnitude and direction. Okay, so if you're given the magnitude and direction, you use basically this or that. Okay, now on the right side over here, we're going to be given the A and the B. So you know the components. So this is given the component form A, comma, B. You want to find the magnitude. So to find the magnitude, you do Pythagorean theorem. Square root of a squared plus b squared. That's just using Pythagorean theorem. And then to find theta, this is a little tricky. You do tan inverse of y over x. Okay, think about that. That's tangent is opposite over adjacent. So if you want to find the angle, you do tan inverse of opposite over adjacent. But look down here. Okay, there's more information down here. This is really important. So that's how you get theta, but you have to, if it's in degrees, you add 180 if it's in quadrant 2 or 3, because the calculator, according to inverses, will only give you quadrants 1 or 4. So you have to add 180 whenever the x is negative. This is important right here. Okay, I'm going to star this. So when your x is negative, whatever you get for your answer, you're going to add 180. You're going to use either Desmos or your Casio. I'll be using Desmos and show you how to do it on my iPad because you all have that. So you can certainly use Desmos. If you have a Casio, just make sure that it's in degrees this time, not radians, okay? All right, so the first one, we're given the magnitude and direction. So that's going to be like the left side, okay? So that's this right here. So it says sketch it and state the component form. So first I'm going to sketch it on a coordinate plane, okay? Let's make these straight. So if I come down like this, and then I go across like this. Okay, so the angle would be 34 degrees. So that's a little bit less than halfway through that, and then the length would be 8. So it's something like this, where this is 34 degrees, and this length is 8, okay? That's your theta. The component form, A, is just going to be 8, which is your magnitude, cosine 34, and B is just going to be 8 sine 34. That's all you have to do. Now I'm going to pull up Desmos. So I have Desmos here. So one thing that you want to do is go to your tools, and you can toggle from radians to degrees. We're going to be in degrees this time. Vectors are usually stated to you, not always, but usually stated in degrees, okay? So go to tools, switch to degrees. Come over here, and we need to type in 8 cosine, what was it? Let's look. 34, okay? So we just type it in up here. So you just go 8, hit your functions, hit the word cosine, and then put your degrees, and then you can end your parentheses and hit enter. the length, the horizontal component would be 6.63. Okay, so I would go, this would be approximately 6.63. And then, and I can do these all at once. I'm going to go 8, hit my functions, go to sign, and then hit 34. And that's 4.47. So if I go back, that's approximately 4.47. So the exact component form would be 8 cosine 34, comma 8 sine 34, or the approximate component form would be 6.63, comma 4.47. And if you look over here, that's basically saying that this goes over about 6.63 and it goes up about 4.47, okay? So that's, if I asked for exact component form, it would be this guy. If I asked for approximate, it would be that guy, okay? That's all you gotta do. All right, so here we go. It says sketch and then state the component form, 10 and 122. So I'm going to sketch it first. Okay, 122 is bigger than 90, and it's going to go out 10. So it would be something like this, where this would be 122 degrees, and this length would be 10. Okay, so A is going to be 10 cosine 122. B is going to be 10 sine 122. My exact component form would be 10 cosine 122, comma 10 sine 122. But I want to approximate that, okay? So I'm going to go to my Desmos, and I'm going to hit 10 cosine 122, and then 10 sine 122. Okay, so I have both my numbers. It's a negative 5.30 and 8.48. Okay, so negative 5.30, 8.48. Negative 5.30, 8.48. Now let's see if that makes sense. Okay, let's come over here. This is saying from the origin, negative 5.30. That looks right. And then up 8. Do you see how that works? It's exactly looking good. All right. Okay. So now sketch the vector and state the magnitude and direction. So this time I'm going to be using the right side of this chart over here because I've given you the component form. And this is when I got to think about the adding 180. If my x is negative, meaning it's in quadrant 2 or 3, I'm going to have to add 180. So sketch the vector. So let's just go ahead and sketch it. When you go over 1, 2, 3, up 1, 2, 3, 4, your vector looks something like that. Okay? So this was over 3, up 4, but this is the vector here. Okay? And I want to know the magnitude and direction. So magnitude is length. So magnitude of v, and I'm going to put those little absolute value looking things, is going to be the square root of 3 squared plus 4 squared. When I do that, I get 5. And so all you do is write that as magnitude of it is 5. Done. Theta is your direction. Okay, so for direction, you just answer theta. This means direction. Okay, and you're going to go tan inverse of y over x, or b over a, 4 over 3. That's when you'll need to go back. We're going to be in degrees again, so we'll go back to Desmos. Okay, we can delete these, and we'll go functions and see how we have tan inverse. And then we're going to hit 4, and then if you hit divided by 3, it makes it into a nice pretty fraction like that. 53.13. So that is approximately 53.13 degrees. And if you look, that looks like it's about 53 degrees, and this would be a length of 5 going here. Okay, so it makes sense. So your answers are theta is approximately 53.13 degrees. So this is an answer magnitude. This is an answer direction. This is direction. Okay. All right. -4/8. Aha. Woo. This is kind of like the red flag when we did the law of sines. I'm going to red flag this a little bit because I see that it starts with a negative. That means when I use my tan inverse, it's not going to be the right quadrant. Let's sketch it and look at what quadrant this is in. Okay. So if I sketch this, -4 would be coming 4 this way, 1, 2, 3, 4, and then F8 would be somewhere here. So the vector itself looks like this, okay? Your theta is here, and then your magnitude. So magnitude's fine. You just have to be a little bit careful with magnitude because you go, the magnitude is, now watch, it's parentheses -4 squared. Or just leave out 4 squared plus 8. Don't even write that. So you'll just come back here to your Desmos. And you can just do calculations. So you'll go 4 squared plus 8 squared. See how it does it? And now I'm still under the square root. So I probably should have put that in the beginning. But I can do it now. Square root of 80. I could have done it all in the beginning. 8.94. Okay? 8.94. So that's approximately 8.94 is your length. Theta is tan inverse. Now, here's the trick when you're doing this. You have to use the positives and negatives. So it's 8, which is my y value, over -4. It's y over x. You have to type it in just like that, and I'm going to add 180 because x was negative. Okay? So let's go to our inverse. All right, we'll delete these. Okay, and then we're going to go over here. Functions, tan inverse, and remember it was y over x, so 8 divided by -4, and it should do it right. It does, and it gives me -63.43, okay? So if I were to say this were -63.43, that's not in the right quadrant. -63 degrees is here. That's why, because it's in quadrant 2, I have to add 180. You have to add 180 whenever it's in quadrants 2 or 3, or whenever the x is negative. So I'm going to go back to Desmos, -63.43. So I'll just go here and I'll go -63.43 plus 180. That gives me 116.57. And so this is approximately equal to 116.57. And that makes a lot more sense, doesn't it? Doesn't that look like 116? So that's your theta. So your magnitude is 8.94 and your direction is 116. You have to add 180 on that guy. Okay? What's going to happen on this next one? Do we need to add 180? Yes, add 180. Okay? So don't forget, make a little note, add 180 because x is negative, okay? It's going to be in quadrants 3 or 4. So here we go. We're going to sketch it. All right, -2, 1, 2, -5, 1, 2, 3, 4, 5. It's going to end up like that. Theta is this big, huge, all the way around thing. So, oh, I'm sorry about my computer. Let me see if I can turn that volume down. All right, so we're going to go, the magnitude of V is going to be the square root of, I'm just not even going to put the negatives because I know they go away, okay? I promise you they go away. That's going to be the square root of 29, which I'll have to use my calculator to approximate. And theta is going to be tan inverse of, and then we'll do -5 over -2. But whatever I get, I know I'm going to have to add 180 because it was in quadrant 3. Okay, the x was negative. So I'm going to go ahead and add 180. So let's go back to Desmos and approximate those. Oops. All right, so square root of 29 was that, 5.39. So this is 5.39. Okay, and then we're going to do the tan inverse of negative 5 over negative 2 plus the 180. So let's watch what happens when I don't. So I'm going to go functions, tan inverse, and it was negative 5 divided by negative 2. Okay, and when I do that, I get 68. Well, that does not look like 68 degrees. So this is where I need to go plus 180 and see if this looks like 248.20. 248.20. Let's look. We got that theta is approximately 248.20. Guess what? All this way around is more than 180. So those answers make sense. So here's the magnitude and here's the direction. Okay? All right, last example. This time, woo, we got to do some work like yesterday's first to figure all this out, and then we'll get the magnitude and the direction, okay? So first we have to figure out what P is. Well, P is V, which is negative 2, negative 5, plus 2U, which is 2 times 4, negative 3, which is 8, negative 6. We're going to add them to get P, the resultant, and that's going to be 6, negative 11, okay? So we're not going to draw it. So now, just to get an idea, 6, negative 11 6 over 6 down 11 would be something like this, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it would go like that, okay? And so theta is going to be all the way around that big guy like that. So your magnitude of P is going to be the square root of 6 squared plus 11 squared. Remember, we're just going to ignore the negatives on this one. Do not ignore the negatives on the tan, and you can put them into this one, but they go away. But do not ignore them on the tan inverse. They're hugely important on the tan inverse, okay? So I'm going to go to my Desmos so you can see. And I'll do the square root of 6 squared plus 11 squared. So 12.53. So the magnitude of P is approximately 12.53. Isn't that what I said? Okay, now theta, which is your direction, is going to be tan inverse. You've got to put the negative, negative 11 over 6. Now, this is in quadrant 4. You can get this big theta or you can get this one. It doesn't matter. Theta can be either one. You don't have to add 180, but you can. So you can get this negative angle if you want to. Let's see what happens when we plug it in. So, okay. So we're going to go functions, tan inverse, negative 11 divided by 6, and it's negative 61.39. So we got theta is approximately negative 61.39 degrees. And that's right. If you want to, you can add 180 to that. And if you add 180 to that, you would get negative 61. You would get theta is approximately, oh no, don't add 180. Just leave it. Don't do that. I forgot. You don't want to do that. Leave it negative. Leave it negative, okay? It's much easier. So there's your theta, there's your magnitude, and your direction. And we're done. Yay.